so here we have the same statics problem we looked at in a previous video. I showed you how to solve the problem using a triangle of forces. This time we're going to look at it by considering a slightly different method. So once again, we've got some kind of rigid support here and here. We've got this 40 Newton weight acting downwards, and then we've got these two cables or strings that are supporting it, and they're attached to these rigid supports. So we've got a force acting to the left horizontally, and we've got a force acting this way up to the right. Now, because this object here is stationary and it's supported by these forces, we call this a statics problem. We say that the object is not moving, so it must be in equilibrium, and the resultant force on the object must be zero, this 40 Newton weight here, okay? So we know that the combined force, the resultant force, must be zero. Right, now if we look at this, this force here, F1, we can split this force into two components. We can split it into a vertical component here, okay, and a horizontal component here, all right? So vertical component, horizontal component. Now, if we call this horizontal component F1H, and we call this vertical component F1V, then we can now work these two out and then solve this problem. Now, if you think about it, vertically, F1, the vertical component of F1 must be equal and opposite to the 40 Newton force in order for there to be no resultant force vertically. And horizontally, F2 must be equal and opposite to F1, the horizontal component of F1. Okay, so you can see they're acting in opposite directions, but they must be equal in magnitude in order to basically cancel out and for there to be no resultant force in the horizontal direction. So from these two things that we've just considered, we can write two equations. So essentially we can say that this, take away this, must equal zero. Okay, now the problem is we need to work out what this is first. We need to come up with an equation for this. So the way we're going to do that is we're going to consider that this vertical component here is opposite to this 45-degree angle. Essentially, we've got a triangle here. We've got the vertical component of F1, we've got F1 itself, and then you could have the horizontal component of F1 here, forming a vector triangle, okay? But we're just considering the vertical component at the moment. So this is a right angle triangle. F1 is the hypotenuse. The vertical component of F1 is opposite this 45-degree angle. So to work out the opposite of a right angle triangle, we need to use sine theta. So we know that this here, this component, this vertical component, is just going to be equal to F1 sine 45. Okay, how do I know that? Well, sine of 45 must be equal to opposite over hypotenuse, and therefore the opposite must be equal to h sine 45, and h is F1, so F1 sine 45 is equal to this vertical component of F1. So that's the vertical component of F1, and we know that if we take away 40 from that, it must equal 0, okay, in order for there to be no vertical resultant force. So this is vertically, whoops, that's supposed to be an A there, okay. Now if we consider the situation horizontally, it's a similar situation. This time, F1H, take away F2, must equal 0. So we could write that perhaps as F1H, take away F2, must equal 0. Okay, because horizontally there must be no resultant force. So how do we work out F1H? Well, if you think about it, you can either consider F1H up here, or you can consider it down here, it doesn't matter. And if you can consider it down here, we know that this angle is 45, so this angle here must be 45 degrees, because if this vector is at 45 degrees to the horizontal, this is horizontal, so it must be at 45 degrees to the horizontal. Again, we could draw a vector triangle here with our vertical component of F1 there, but we don't need to worry about that because we've already dealt with it. So F1H in this situation is the adjacent to this 45-degree angle. Again, this is the hypotenuse. So this time we've got cos 45 is equal to adjacent over hypotenuse. So the adjacent is equal to H cos 45, which is F1 cos 45. And the adjacent is this horizontal component of F1, as we said. Okay, so what we can do now is instead of F1H, we can write F1 cos 45 because that is the horizontal component of F1. So F1 cos 45 take away F2 must equal 0. So we've now got these two equations. Okay, now the top one is really easy to solve, so we'll do that one first. F1 sine 45 is equal to 40, because when we take that negative 40 over this side, it becomes a positive 40. And therefore, F1 is equal to 40 over sine 45. Okay, and if you type that into your calculator, you will get your answer, which is going to be 56.6 newtons. Okay, and we could just round that to 57 to two significant figures like the data was that we used to begin with. Okay, so now we know what F1 is, we can then substitute it into this equation to work out what F2 is. So we know that, so this is F1. So with this equation now, we can rearrange this equation to get F1 cos 45 is equal to F2. Okay, so F2 is equal to 57 cos 45. And again, if you put that into your calculator, you're going to get 40 newtons.